Good afternoon. Today I will be discussing a 2002 journal article titled Neural Systems Underlying Lexical Retrieval for Sign Language, taken from the journal Neuropsychologia. Authors and researchers listed on the slide search for answers to whether or not sign languages show the same type of neurological organization as spoken English when retrieving words within the classical and non classical language areas. Classical areas are described as unique entities such as famous people, and non classical areas are described as non unique entities such as animals. The researchers hypothesized that the retrieval of American Sign Language, either fingerspelled or established signs, will activate areas in the left hemisphere of the brain similar to the retrieval of words spoken in English. Specifically, they hypothesized that the left supramarginal gyrus, a specific area of the brain that plays a role in phonological processing and the perception of space and limbs location, such as posture and gestures of people, would be more engaged during the production of an established sign than a fingerspelled word. In order to test this hypothesis, researchers conducted a PET experiment with 10 right handed adult native deaf signers. Researchers conducted magnetic resonance or MR scanning on each subject, which allowed researchers to look at cross sectional or slices of the brain. Each subject received a total of 8 injections containing 50 MCIs of water, which helps identify activation. They performed 4 tasks twice each. The 4 tasks included production of names for famous persons using fingerspelling, production of names of animals using fingerspelling, production of names of animals using native ASL signs, and an orientation judgment performed on the faces of unknown persons. The 4th task required a yes or no answer on whether or not the picture of the unknown person was inverted in order to elicit a signed response of yes or no, being that an unknown face cannot be named. Some of the conditions of these tasks included that the pictures were presented 5 seconds after each water injection and remained until 40 seconds after the injection. The animal pictures that had a native ASL sign were shown first so that subjects would not fall into a finger-spelled set where they would give a finger-spelled response for all tasks. The picture of faces were black and white with the background deleted. The familiar faces were selected by the subject prior to the experiment from a large collection of famous faces. Unfamiliar faces were half male and half female, and half of them were inverted. Animal pictures were digitalized color photographs, and the background details were also deleted. At the end of the study, the prediction that the retrieval of signs for animals activated the same areas in the brain as hearing speakers when naming animals was correct. Similarly, the activity that was predicted for naming famous persons was also the same for English speakers. Surprisingly, naming persons in ASL and the unfamiliar faces task revealed an activation in the area of the left hemisphere, unlike what was reported for English speakers. This additional activation may be due to the fact that deaf signers have a different perceptual and cognitive experience of faces, specifically facial expressions, which play a significant role in creating sentences and forming words in ASL. Finally, the left supramarginal gyrus was activated in the retrieval of native ASL signs for animals. Few reports can be found that the same area is activated during spoken word production in this task. As you may recall from the introduction, the SMG is involved in the perception of space and limbs location. Because signs require the location on the body to be specified, such as apple signed by the chin as opposed to onion with the same hand shaped near the eye or forehead, it is possible that activation of the SMG is unique to sign languages. To conclude, this data reveals that the same areas of the left hemisphere of the brain are engaged in the retrieval of words and signs. Therefore, language modality does not affect how we neurologically process words. This research is important to both deaf and hearing communities because there are many common misconceptions about ASL and how it compares to spoken language. One of the biggest misconceptions is that there is some type of deficit in the sign languages compared to spoken languages. Misconceptions in the ASL language and deaf culture in general lead some to believe that ASL is a less intelligent language than spoken languages, or not even its own language at all. This study helps to emphasize the fact that while signed and spoken languages are vastly different, the brain shows us that no matter how different the languages are, the way we access and process these languages, at least for ASL and English, are quite similar. Thank you.